Hello class. This is a video to help you get started with assignment 4. I posted assignment 4 yesterday, so you can go to Web Campus, wherever that might be, probably on your internet browser, and you can go look in the files section and you'll see there that I've uploaded everything that you need. So let's kind of just go through that real quick. The purpose of this assignment is to practice using pointers, which we're going to discuss in class today. So if you missed class or you need a refresher, please go watch that YouTube video for the class today, which is September 23rd. All right, so if you come to assignments here, you'll see assignment 4 is down here. Now, I don't do any of this fancy stuff. I say, please go look at the files tab, okay? So we'll go do that. And you'll see that we have it here, assignment 4. And you'll see you've got your sample output. There's just one file in there. You see that you've got your PDF here, which we'll go over very briefly. And you'll see that in this coding file section, I've given you every file that you need. A whole 10 files. Pretty crazy. But I assure you there's nothing to worry about. And this assignment should be pretty fun. So once you do that, and you open up the assignment, this is a PDF that I created just like the last one. Okay, so you know that my PDFs are pretty detailed. They can be kind of long. But of course, I'm just giving you every detail that you need, okay? So I'll let you read the introduction. Basically, this is how this game works. A musical, I'll even pull up main for you. Let's see here where we are. I think that will do. Basically, we're going to use a musical chairs class, okay? There's a musical chairs game class. And so we're going to declare an object like we do here. Let's see. This is the main file that we're testing. Look at how big it is. Isn't that amazing? We're going to declare a musical chairs game object, and then we're just going to play a few rounds of musical chairs. That's it. So we're going to declare that object. It can be initialized with between 2 to 9 players and 2 to 9 chairs. And there will never be more chairs than players. So the way that the game works is, say you put in 8 players and 9 chairs. The game will actually set that back to be 8 chairs, because there would be no point in playing around where there's just as many chairs as there are players. So that's what that means. A grid of 11 wide, 3 tall spaces is used to host the game. A space can have an empty chair, a chair with a seated person, a standing person, or nothing in it. So let's look at this example here. You can see this is the 11 by 3 grid. It's 11 wide, it's 3 tall. A space can have a chair in it, that's represented by this C. A space can have a person in it, that's represented with their ID number. Or the space can have a seated person. So that's a chair with a person sitting in the chair. So that's the person's ID in brackets, okay? The chairs will always be side by side in the middle row, always starting from grid 1-1. So you notice the C here is kind of starting 1 over here to the right. There's an empty space here. And that's because people need some room to get around it if they're going around the side of the chair. All right, so it always starts at grid 1-1, and then they'll all be lined up to the right side here. People will always line up here in the starting position, grid 0-0 to the right. So this is always the starting position. And then before the game starts playing, we're going to remove a chair. So in this example, I actually declared 9 players and 9 chairs. But before the round starts, a chair is removed. So the 9th chair that was here gets taken away. Now the game's going to operate in half-second game ticks, or a cycle, if you'd rather call it. Each tick, some music will play, and a player may move 1 space or completely around the corner of the chairs. This has to do with the rotation of the players. You're going to write that function. So you notice here, kind of from up here, you'll see that, well, let's just do an example here. Let's look at this example here. then some music plays, you'll see that this player 2 is actually going to rotate completely around the chairs here. So 2 comes all the way down to the other side. And 3, 4, 5, 6, 7, 8, they all move 1 to the left. Some more music plays, you'll notice that 3 comes all the way down here, and then all the rest kind of rotate that way. Just like 2, 1, and 0 are rotating to the right. All right. Now, the music has a 10% chance to stop. If the music stops, all of the players will scramble to grab a chair. And this is done randomly. I kind of wrote that function for you. And so everyone will try to grab a chair. Of course, not everyone will get a chair. So you notice everyone here gets a chair except for person 7. And they're just kind of left out here in the open. The players who did not make it in any chairs will be removed from the round. So player 7 will be removed. And then all players will then stand up for the next round. So that's how the program works. There's actually 10 total files, but one of them is a make file. There's 9 coding files. So there's a header and an implementation file for every class. So the person, the chair, the space, the musical chairs, and main. Okay. Now you're responsible for coding everything in the CPP files for these classes. Okay. You got to code everything here and here. I've given person to you completely, and I've given this one to you mostly. All right, let's look at them in the Visual Studio Code. We are in the student folder here, so if we pull them all open, notice that person H, person.cpp, completely given to you. It's a very simple class. Now space.h, I've given it to you. Space.cpp, you got to put in all of the code. But I gave you the skeleton. Now you'll see here, some of these return false. The reason that is, or they return, say, -1. The reason that is because I want the code to compile right off the bat for you. That will kind of allow you to work backwards, maybe from your errors if you're confused. But these return statements, you may need to replace them. In some cases, you might just leave them there and then code something above it and kind of put some different return statements. For example, this get person ID. If there is an error in getting a person's ID, you're always going to return -1. So you might just leave this here, and then somewhere up here, you're going to put a different return statement. All right. Similarly, chair.cpp, you have to do that stuff. H is given to you. And then here's the big one. Main, I showed you. Make files here. Now, musical chairs. I did almost all of it for you except for this bit, so I really tried to make it pop. You've got to do the everyone rotate counterclockwise function, but everything else is given to you. Now, all of these, you'll notice I didn't really give you many comments, are described in detail, even for the functions that I gave you. So everything in the person class here is explained, even though you don't have to code it, all right? So this is for you to reference the PDF. You say, I don't know what that does. Well, go ahead and come in here and take a peek and then figure out what it does. All right. Now I've explained everything in detail here for the chair. I've explained everything in detail here for the space. Just follow along. And then finally, musical chairs. This one is pretty detailed. It's a big class. Now I literally gave you everything that I did. The only one that you need to pay attention to, obviously, is this one. And I should rephrase that. You should pay attention to all of them. But this one is what's going to tell you how to code that one function in that class. Okay? After you do that, you can compile your code using make, and you can submit your stuff to CodeGrade, and that's it. So let's go ahead and do an example program run. Here I am on Bobby. I've uploaded all 10 files. And so all I have to do is type make. I guess I should change my directory to the one that I'm working in. You'll notice that everything compiles. Now this make file is much simpler than the other one, so if I keep typing make, it's just going to keep recompiling it, all right? So that's going to be a little bit different from assignment 2. It's a very simple make file. Now, when you run it, just type ./a.out. It's going to clear the screen, and it's going to ask you how many players there are. And so I'm just going to go ahead and pick 2 to start. And the number of chairs, I can pick 1. But that probably won't work out very well. It will probably set it back to 2, right? I can't pick 1. It says 2 to 9. So it could pick anywhere from 2 to 9. Obviously, if I pick 9, it will decrement it back down to 2. And that's because we're not going to play with more chairs than there are players. So I'll just type 2 here. And so the game starts playing. Now that was a quick little game. Let's kind of go through here and look at what happened. We print out there's 2 players, 2 chairs. We're going to remove 1 chair. So you notice that there's only 1 chair here. And the 2 players are lined up here. So the music starts playing and they start rotating. You'll notice that they move here to here to here. And then the music stops. So they're going to scramble. And somehow player 0 managed to beat player 1 to the chair. Alright, and then it says player 1 lost and player 0 won. So now let's run an example of this with 9 players, and you can actually really see them rotating around. It's quite cool. So I'll type 9, and then you'll see here that they just kind of start rotating. And they'll keep rotating until that music stops. Like I said, there's a 10% chance that the music will stop. There they go. Player 6 lost. Now they continue on with the game. Player 2 lost. They continue on with the game. You can't see the person who lost there. They were hidden behind my face. That was a quick round. They're rotating around. They lost. Rotating around. And you'll see that player, I don't know who loses. We'll just have to watch and see. All right, player 4 lost. So, player 5 won, and that was the whole game. So you can kind of run this and play with it. This is very important. You should always use Valgrind. So here's what I would recommend. If you want to see where your memory errors are failing, so this is actually a big part of this assignment. If you come look at the code grade, you'll notice that 45 points are going to be given to you if you have no memory problems. Okay? Also that your output will match. So almost half of the assignment is based off of not having any memory problems. So these are count as invalid reads, memory leaks, aliasing, a bunch of stuff like that. And so you wonder, how am I going to check that? Well, this is exactly how you should do it, is what I recommend. So what you're going to want to do is you're going to want to compile your code like it is in the makefile. In fact, you can just come inside of the makefile and maybe change it up a little bit. Let's go look at it. So notice it's all in here. Now, all you need to do is actually add a -G on the end of it. Now, what that -G does is it makes it so it puts in what's called debug symbols. And the debug symbols basically make it so you will, when you see error, it will actually print the line number that the error was from. If you don't include that -G, it just includes some memory address, which is not very readable for us. So I'll type make here. And you'll see that if you get this warning, it's kind of an issue. So I'm just going to log out and then log back in. And that will fix your problem. Like I said, I'm not a makefile master. It is a simple makefile. Now it works fine. All right. So now that that's compiled, let's pretend I go in my code and I make a little error. Now I'm going to go do that for you real quick. Let me go ahead and black out my screen, just so you don't see anything that you're not supposed to see. And I know exactly what error that I should make. I'll come in here, and then down here, I will make this go out of bounds. Oh, this is the student. Whoops. All right. So all I'll do is make this go out of bounds. Save it, upload it. Let's try again. You notice now Valgrind will say something to me. I don't know if the program will complete. It might do it, it might not. but I'm going to recompile it. Of course, things worked, right? And as soon as I /a.out, it will just run. Now, if I /a.out it like normal, and just do 2 and 2, it looks like there's an error here. You see player 1 is not moving, but the program did run. Now let's use valgrind. So to use valgrind, I would type valgrind -- leak - check equals full space. Now let's run it. I'll do 2 and 2, and let's see if we get an error. Now it looks like I actually had no memory errors there. It looks like the error I just made was a functionality error. So let me go ahead and really make a memory error. All right, I think this will do it. I'm going to try one more time here, and I'll even check myself. All right, we'll run a make, and we'll run a valgrind 2 2. Ah, perfect. Okay. So I got it to make a memory error. So let me show you here. I'll bring back the class. So if I run this, just normal. I'm just going to run it by normal. 2 and 2. You'll notice that the game works like normal. So you'll get full points for that. But then you say, my memory is failing. Well, I'll show you why. If I run valgrind, I'm actually going to shrink this just a little bit. Boom! You see this error popped out. This error popped out. What did it say? Well, apparently we had no memory leaks, but you'll see here that this error says there's a conditional jump that depends on an uninitialized value. And it says, where should I go look at this? Well, it says maybe you should go look at this function here on space.cpp line 69. Or, if you don't see anything wrong there, go ahead and look in your everyone rotate counterclockwise function on line 201, which was then called by seat random person, called by this, called by that, called by that. So valgrind tells you exactly where you should go look for this stuff. And that's how you can work towards fixing your memory problems. So give this assignment a shot. I'm hoping it'll be a fun one. It shouldn't be too hard. All right, it shouldn't be too hard. You just kind of an introduction to pointers. Best of luck to you guys. I'll see you in class, and come to office hours if you need. See you next time.